Hello everyone, in this video I'm going to discuss the example for differentiation. The parametric equation of a curve is given by the situation where we have the x, which is equals to 2, bracket, we have the t squared minus 1, power of negative 1 over 2. And we have the y, which is equals to, we have the square root, or we can say the t squared minus 1 to the power of 1 over 2 over the 2t. Question asks us to show that we have the dy dx, which is equals to the situation given. So let's begin. We have the dx dt, which is equals to negative 1 over 2 multiplied with the 2, bracket, t squared minus 1 to the power of negative 3 over 2, bracket, focus on the internal function, and we have the 2t. Rewrite the situation. So we have the negative 2t over the square root of t squared minus 1, bracket, to the power of 3, dx dt. Differentiate, we have the dy dt, which is equals to, make use of the quotient rule, we have the 2t, bracket, differentiate the u, where we have 1 over 2, bracket, t squared minus 1 to the power of negative 1 over 2. Focus on the internal function, so we have the 2t, minus t squared minus 1 to the power of 1 over 2, differentiate the 2t, and we have the value 2, over, we have the 2t, bracket, square. Can you simplify the situation? 2t, we have 4t squared. Multiply with the 1 over 2, so we will have 2t squared. So 2t squared over the square root of t squared minus 1. Minus, we have the 2 multiplied with the square root t squared minus 1 over the 2t bracket square. Can we equate the denominator? So meaning that what we have to do is to multiply square root of t squared minus 1 over t squared minus 1. So kindly expand the situation. 2t squared minus, we have the 2. Then if we expand this part, we will have negative 2t squared. Continue, we have the positive 2 over, we have the 2t bracket square multiply with the square root of t squared minus 1. Finally, we have the situation 2 over, we have the 2t bracket square multiply with the t squared minus 1. That is our dy dt. So next we have the dy dx, which is equals to, where we have the situation 2 over, we have bracket 2t bracket square root of, we have the t squared minus 1 multiply with, we have the dt dx, where we have the square root, we have t squared minus 1 bracket to the power of 3 over the negative 2 t. Continue, simplify the situation, and we have negative. So based on the situation here, we have the 2. Simplify. Then we have the square root of t squared minus 1. So in here, we will have negative bracket t squared minus 1 over, we have the 2t bracket square. Multiply with the t. 1 minus t squared over, we have the 4t bracket cube. So that is our dy dx. Then we already shown the situation given in here. Hence, find the second derivative when the t is equals to negative 1. So if we substitute in this part, t equals to negative 1, then we will have the dy dx, which is equals to 1 minus bracket, we have the negative 1 squared. So which means that we have 1 minus 1. So the dy dx is equals to 0. Next, find the second derivative. So here we have the formula for the second derivative. So we have to differentiate the dy dx with respect to t. Multiply with the dt dx. So let's begin. So based on the situation here, we are going to make use of the quotient rule. 4t cubed bracket, we have negative 2t minus 1 minus t squared bracket, we have 12t squared over, we have 4t cubed to the power of 2. Multiply with the dx dt. So focus on this part, and we have the situation square root t squared minus 1 to the power of 3 over negative 2t. So kindly substitute the situation. So if we substitute the t, which is equals to negative 1, so in here we have 4 bracket negative 1 bracket, we have the 2 minus bracket, we have 1 minus bracket, we have the 1. multiply with the 12 over the 4 bracket, we have the t, which is equals to negative 1 cube. Then we have the square. Then multiply with the situation. So focus on here, we have the square root. So t squared, where we have 1 minus 1 bracket power 3 over we have the 2. So based on this part, we obtain 0. So meaning that anything. So here we have the situation negative 8 over the 4 multiplied with the 0. So the second derivative, which is equals to 0 when the t is equals to negative 1. Next, continue. If y is equals to cos bracket 1 plus with the x squared, prove that we have the situation given in here. So at first, kindly differentiate for the first derivative where we have the dy dx, which is equals to negative sine bracket 1 plus with the x squared bracket. Focus the internal function and we have the 2x dy dx, which is equals to negative 2x. Then we have the sine bracket 1 plus with the x squared. Continue. Find the second derivative. So we have the second derivative. Make use of the product rule. So we have the sine bracket 1 plus with the x squared. Differentiate the negative 2x and we have negative 2. Plus, we have the negative 2x. Differentiate the sine and we have the cos bracket 1 plus with the x squared. Focus the internal function. So we have the 2x. Rewrite the situation. So we have the second derivative. Negative 2 sine bracket 1 plus with the x squared. Then minus 4x squared cos bracket 1 plus with the x squared. Rewrite the situation. So at first we have the second derivative, and then we have the situation plus the 2 sine bracket 1 plus with the x squared, plus we have the 4x squared bracket cos bracket 1 plus with the x squared, which is equals to 0. So kindly refers to this part where we have the y. So rewrite the situation. Second derivative plus with the 2 sine bracket 1 plus with the x squared, plus we have 4x squared and then y, which is equals to 0. So basically we have already showed this part and also this part. Next, focus on this one. So by referring to this part, rewrite the situation. So we have the dy dx, which is equals to negative 2x sine bracket 1 plus with the x squared. Rewrite the situation. Sine bracket 1 plus with the x squared equals to, we have negative 1 over 2x multiply with the dy dx. So maybe we can substitute the situation. So for this case, we have the second derivative plus we have the 2 substitute. Then we have the negative 1 over 2x and then we have the dy dx plus with the 4x squared y, which is equals to 0. So finally, if we simplify the situation, then we have the second derivative and then we have the negative 1 over x dy dx plus with the 4x squared y, which is equals to 0. So kindly refers to this part and notice that we already show the situation. Given the equation, a curve is where we have exponent 2y plus exponent 3x plus we have 2x multiplied with the exponent xy, which is equals to 0, and we have the situation x equals to 0 and y equals to 0. Question asks us to find the gradient where we have the dy dx. So kindly differentiate the situation. Exponent 2y, differentiate, we have the 2y prime. Plus exponent 3x, we have the 3. Plus we have the situation bracket exponent xy, differentiate the 2x and we will have the 2. Plus we have the 2x, differentiate the exponent, we have exponent xy bracket. Again, product rule. We have the y plus we have the x, then we have the dy dx, which is equals to 0. So kindly substitute x is equals to 0, y is equals to 0. Then we notice that exponent 0, which is equals to 1. So here we have 2 dy dx plus we have the 3 plus bracket we have 2 bracket the 1 plus we have the 0 multiply with y where we have 0 plus we have the 0, then we have the dy dx. which is equals to 0. So kindly rewrite the situation. We have the 2 dy dx plus eta 3 plus eta 2, which is equals to 0. So we have negative 5 over 2. We have the dy dx, which is equals to negative 5 over 2. If you are new here, kindly consider subscribing to this channel and share this video to your friend. Thank you so much for watching this video. Bye.